Welcome everybody. My name is Lucy Stamm and I am a Global Product Manager at Miltenyi Biotec. Today I am happy to introduce our automated hematopoietic stem cell engineering process on the CliniMACS Prodigy cell manufacturing platform. This process enables the manufacturing of gene-engineered HSCs by viral transduction. Let's have a look at today's agenda. We will start with a short introduction of Miltenyi Biotec and its cell manufacturing platform, the CliniMACS Prodigy. Then Katharina will tell you how to enrich HSCs with our CliniMACS Prodigy HSC Enrichment process. Next, I will present you the CliniMACS Prodigy HSC Engineering process before Eleni will show you some performance data. Advancing the field of cell and gene therapy is at the heart of Miltenyi Biotec. For more than 3 decades, we have basic researchers, clinical investigators, and biopharmaceutical companies to discover and harness the power of immune cells for cellular therapies. With our expertise in providing reagents, instruments, and services from research to clinical grade, we are unique in enabling investigators to take early discoveries to clinical translation and commercial manufacturing. Our CliniMACS Prodigy cell manufacturing platform is an all-in-one solution for your cell manufacturing endeavors. It can fully automate your process in a functionally closed manner with in-process and quality control sampling. Its flexible software allows you to translate your manual protocol. Importantly, the CliniMACS Prodigy platform has been used in more than 180 clinical studies. Up to now, we have developed various CE and GMP verified processes for different applications, from engineered T cells over to NK cells and stem cells. Additionally, our customized application services, short CAP, can help you to create tailor-made solutions in case where user requirements are not covered by our pre-installed software applications. As you can see, we have 2 processes at the moment for the engineering of HSCs. First, the HSC enrichment process, and then the HSC engineering process. And in the next few minutes, Katharina and me would like to present these both processes in more detail to you.
So let's start with HSC engineering workflow. This is what a manual manufacturing process usually looks like. Of course, you need to start with documentation of incoming material, sample processing, and HSC enrichment. Several other manual handling steps will follow until you get your final engineered cell product. However, there is also a possibility to automate this process on the CliniMACS Prodigy. In this automated process, you will have 2 major steps: HSC enrichment first and HSC engineering second. Within the next couple of slides, I will describe the first part in a little more detail, and then Lucy will go ahead and will give you more details on the HSC engineering process. Here you can see the different process steps. The cell bag with mobilized leukapheresis is connected to the tubing set and is automatically washed a couple of times to remove the platelets. Afterwards, cells are magnetically labeled with a CliniMACS CD34 reagent. The next step is optional. For up to 16 hours, the labeled cells can be stored in the cooled chamber of the tubing set. Depending on your desired process end time, the storage length is calculated automatically. Finally, the labeled cells are magnetically enriched, and after approximately 4 hours of process time, you can obtain your highly pure CD34 positive cells. However, the exact process time depends on the number of white blood cells you start with. All these mentioned manufacturing steps are performed automatically within the closed tubing set on the CliniMACS Prodigy instrument. All relevant process parameters are summarized on this slide. As a starting material, we recommend fresh mobilized leukapheresis. Depending on the number of white blood cells in the start product, the system automatically calculates which version of the process will be used, either normal scale or large scale. For the normal scale process, you need 1 vial of CliniMACS CD34 reagent and 2 vials are needed for the large scale process. The starting volume is between 50 and 600 ml, and the volume you will retrieve from the target cell bag is around 80 ml. And as mentioned before, the whole process takes around 4 hours. So let's have a look at the performance of the HSC enrichment process. Here I want to share data of 12 runs done in-house on fresh mobilized leukapheresis. First of all, you can see that the yield can vary depending on the quality of the starting material. Here between 52 and 84% with a mean of 66%. The purity of CD34 positive cells was between 84 and 95% with a mean of 91%. The log T cell depletion was between 3.76 and 4.76 with a mean of 4.43. With this slide, I want to conclude that the HSC enrichment process shows a very good performance with high viability, purity, and yield. As the whole process is automated, only a few preparative steps need to be done, so the hands-on time is really minimal. Due to the full automation, the process is highly standardized and also user-independent. All steps are performed in a closed tubing set, so the cleanroom requirements are low as there are almost no open handling steps. I also mentioned the optional storage under cooled, controlled conditions, giving you the possibility to receive the target cells at a desired end time. For example, the process can be run overnight and you receive the cells in the morning. And all in all, the process is very robust with gentle cell processing and automated failure handling procedures. With that, I'm at the end of my part and would like to hand over to Lucy to introduce the HSC engineering process. Thank you very much.
Thanks, Katharina, for presenting the HSC enrichment process. Now I would like to tell you more about the HSC engineering process. To start the HSC engineering process, the cell bag containing enriched CD34 positive cells needs to be connected to a new tubing set installed on the CliniMACS Prodigy instrument. After transfer into the chamber, the cells will be pre-cultivated in HSC Brew GMP medium, supplemented with max GMP cytokines. In the next step, the CD34 positive cells are genetically modified by viral transduction. If required, several transduction rounds are possible. After transduction, the final product of gene-engineered HSCs is harvested. The total process time depends on the number of transduction rounds and typically varies between 2 and 3 days. Miltenyi Biotec supports the entire HSC engineering workflow, from connecting the cell bag over to harvest of the final product. The required material includes the CliniMACS Prodigy instrument, as well as the tubing set 520 that I will introduce on the next slide to you. Furthermore, our HSC Brew GMP medium, together with our max GMP cytokines, provide the ideal culture conditions for your HSC engineering process. The lentiviral vector belongs to the flexible part of the process and can be purchased, for example, from Miltenyi Biotec. As said, the HSC engineering process is performed in a tubing set 520. This tubing set for single use builds the functionally closed system in which all steps are performed. On the right side, you can see the setup of the tubing set 520 for the HSC engineering process. Now let's have a closer look at it. The first step of the HSC engineering process is the installation of the tubing set 520 onto the CliniMACS Prodigy instrument. The cellular starting material, which is enriched CD34 positive cells, is in a cell bag that needs to be connected to port 8 of the CliniMACS Prodigy. The HSC Brew GMP medium is connected to port 3. The separate cytokine feeding step is a very important feature of the HSC engineering process, as this significantly reduces the costs for the cytokines required for HSCs. For this, we have a cytokine bag connected to port 4 to supplement the HSC Brew GMP medium in the chamber accordingly. Furthermore, we have a viral vector bag which is connected to port 5. So now that the cell bag as well as the other bags are connected, the pre-cultivation can start and the CD34 positive cells are transferred to the chamber that contains HSC brew GMP medium and MAX GMP cytokines. This step is termed culture setup, and there are two possibilities from which the operator can choose. These two culture setups are the predefined one and the flexible one. These two setups differ in the cell concentration and number of washing steps, but let's have a closer look. The predefined culture setup contains a cell washing step with medium. The cell concentration in the chamber is 1 million cells per milliliter, so based on the starting cell number, the culture volume will be automatically calculated to reach 1 million cells per milliliter. With the flexible culture setup, you can choose whether to include a washing step or not. If, for example, your CD34 positive cells are already in HSC brew GMP medium, you may save time skipping the initial washing step. Furthermore, you can decide on the culture volume within the range of 40 to 200 milliliters, and the cell concentration will vary accordingly. Either way, the selected culture setup will run automatically, including medium and cytokine feed. Now, the CD34 positive cells are in the chamber, and the next step would be to perform the viral transduction. In order to do that, the operator can build its own protocol by combining various predefined activities within the so-called activity matrix. All available activities are listed here and include, for example, the activation and deactivation of the chamber shaker, addition of fresh medium, volume reduction, transduction, or culture wash. As you can see, these activities, when being sequentially performed, recreate a typical transduction procedure. Within the activity matrix, the operator can combine these activities as needed and define the day and time at which these activities are being performed. Now let's have a look how to fill the activity matrix for viral transduction. To build the activity matrix, we would start with activating the shaker. Then we would add medium, as well as cytokines. Then for the transduction procedure, we would use the activity transduction. After transduction, we might add a washing step to remove remaining vector before, in the end, harvesting the final product. Here we will choose the activity end of culture. The fields for day and time are still empty and need to be filled by the operator according to the protocol. As you can see, this is a typical activity matrix for the viral transduction in the HSC engineering process. In general, however, there are three options for building the activity matrix. We have two predefined activity matrices for viral transduction with one hit or with two hits. And you can choose, based on your vector and expected transduction efficiency, whether to perform one or two transduction rounds. Moreover, we have a third option, which is the customized setup. Here, the activity matrix is empty and needs to be filled completely by the operator, according to their needs for full flexibility. After viral transduction, the final cell product, so gene-engineered HSCs, is being harvested automatically with the activity end of culture. This activity consists of two washing steps, resuspension of the cells in 100 ml of physiologic sodium chloride solution with 0.5% HSA that comes from the formulation solution bag connected to port 6. Now, after having presented the process details, I would like to sum up with showing you the process specifications. The cellular starting material is enriched CD34 positive cells, for example from mobilized leukapheresis. The minimum cell number is 20 million cells. According to publication, the cell number should be scalable up to 800 million cells in 200 milliliter, which would result in a cell concentration of 4 million cells per milliliter. The recommended culture volume of the HSC engineering process is between 40 and 200 milliliter. Now let's come to the transduction conditions. The MOI of the used vector will always depend on the used vector and the application. The transduction is performed in HSC brew GMP medium with 2% HSA and max GMP recombinant cytokines SCF, TPO, FLT3 ligand, and IL-3. The process time takes 2 to 3 days, depending on how many transduction rounds are being performed, and the typical hands-on time is around 2 hours. The final product of this process are gene-engineered CD34 positive cells, which are harvested in 100 milliliter physiologic sodium chloride with 0.5% HSA. An important note, the HSC engineering process shows a good recovery of about 90 to 110% of cellular starting material. With this, I come to the end of my part and now would like to hand over to Eleni, who will show you some performance data.
Thank you, Lucy. So let's start with an overview of the HSC engineering process. The overall process is rather short and usually takes more or less 48 hours. We start on day 0, which is usually a Wednesday, when we receive the mobilized apheresis. First, the CD34 enrichment is performed on tubing set 310, as Katarina described before, and then, once the CD34 enrichment is through, we take the target cell back from tubing set 310 and replace the 310 with the tubing set 520 on the CliniMACS Prodigy. Then we connect the target cell back, which usually contains 1 to the power of 8 CD34 positive cells, and we start the HSC engineering process. The HSC engineering process starts by pre-cultivating the CD34 cells overnight in the presence of our HSC brew GMP medium, supplemented with FLT3, stem cell factor, IL-3, and TPO. The next day, on Thursday, the cells are washed and the vector is added. We performed our experiments with one transduction round of a GFP lentiviral vector of GMP grade at an MOI of 30 and at an MOI of 100. The cells are incubated with the vector overnight, and the next day, on Friday, the Prodigy washes the cells to remove the virus and resuspends the cells in the appropriate buffer, which is suitable for infusion. Approximately 500 cells are then seeded on semi-solid methylcellulose medium for CFU analysis, and a portion of the cells remains in bulk culture for several days for quality control, which includes the following: recovery of viable cells on day 2, on Friday, after the process is over, transduction efficiency by flow cytometry on day 5 for identification of GFP positive cells, vector copy number, i.e. VCN analysis by real-time PCR on day 16, and measuring the total number of CFUs per 250 cells on day 16. Transduction efficiency is also expressed as a percentage of GFP positive colonies. It would be also important to say here that parallel experiments are performed by using open manual steps in small scale, and these are also assessed accordingly with the assays I described shortly before. Here are the results of the cell recovery on day 2 after the initiation of the HSC process. On the y-axis, you see the recovery expressed as percentage of viable cells of day 2 compared to day 0, i.e. at the beginning of the process. For example, if we started on Wednesday, which would be day 0, with 10 to the power of 8 CD34 cells, and ended up on Friday, which would be day 2, with 10 to the power of 8 CD34 cells, then the recovery would be 100%. As you see in this slide, the cell recovery retrieved from the CliniMACS Prodigy had significantly lower variation compared to the open manual steps and was close or even higher to 100%, even at the high MOI of 100. Here are the results of the transduction efficiency with the 2 different MOIs from flow cytometric analysis of bulk cultures on day 5 by comparing the results from the manual and the results retrieved from the CliniMACS Prodigy transductions. As you see, the results with a high MOI were comparable to the manual steps, but with less variability. On the contrary, we experienced significantly higher transduction efficiency at the low MOI of 30 with the CliniMACS Prodigy. These findings were corroborated also from the CFU analysis, although I will not show these results in the interest of time. In this slide, we see the results of the vector copy number analysis. As you see on the right bar chart, the VCN was comparable between the Prodigy and the manual steps for the high MOI of 100 and a little higher for the Prodigy, although not significantly higher, for the experiments performed with a low MOI of 30. So with this, I come to the end of my presentation, where I would like to again highlight the key benefits of the CliniMACS Prodigy HSC engineering process. It is automated and thereby not only reduces hands-on time, but also reduces user influence, leading to robust performance, reducing donor variations. This is reflected in the results I presented to you as significantly lower variability, at least in the cell recovery and in the transduction efficiency. In addition, the cell manufacturing takes place in the functionally closed tubing set to increase product and operator safety. And finally, its flexible software allows for easy conversion of your manual processes. And with this, I hand over again to Lucy.
Okay, great. Thanks a lot, Eleni. So now we come to our closing remarks. We've introduced our workflows for enriching CD34 positive cells and manufacturing gene-engineered HSCs with the CliniMACS Prodigy instrument. In case you want to find more information, visit us at miltenyibiotec.com, CD34 cell enrichment, and miltenyibiotec.com manufacturing HSCs. Or contact us to request more information on miltenyibiotec.com Prodigy contact. And now we would like to thank you very much for your attention